Hello, in this lesson 5.2 we're going to learn how to simplify expressions, and we'll be doing that in two ways. We'll be doing something called combining like terms, and then we're also going to take a look at something called the distributive law. If you remember back to when you learned fractions, you learned about like terms in terms of a denominator, like fractions or unlike fractions, so we can apply that knowledge here in algebra. If you have a term that has the same variable, or if you have variables like x, y, so examples here are 12a, negative 2a, or even a fraction, half a, so your coefficient can be positive, negative, fraction, or decimal. These ones are called like terms because for the variable a, they are identical. So we don't have a squared and a to the first power, which is what all of these are. They're a to the first power. So everything about that variable is identical. If we look at ones that are unlike, for example, 3a, 4x, a constant like 4, and 4y, they are unlike terms because the variables are different. And in the case of the number 4, the constant, there is no variable at all. If we have like terms in an expression, we can combine them. So that means we can simplify. So for example, if you have a like term like 3a, and you have a like term like 5a, and you want to add them, you can combine the coefficients together. So you can make them into 8a. Same thing goes if you had something like 8b squared, negative 2b squared, and a positive 3b squared. You could combine all of these by combining their coefficients because they are b squared, b squared, b squared. So the variable must be the same and the exponent of the variable must be the same. You cannot combine b with b squared. So unlike terms would be, for example, b squared and 8b. Even though they have the same variable, the exponent on the variable is different. Same thing goes if you have 3a and you have 3c. The variables are different. Therefore, these are unlike terms. So let's simplify these expressions by combining the like terms. For number 1, we see we have 2x plus 3x. So if you think of it like having 2 apples plus another 3 apples, if x represents apples, then we can add the coefficients. 2 plus 3 is 5. And the apples don't change, and neither does the x. So this becomes 5x simplified. For number 2, we have 5x minus x. Remember the invisible coefficient. Just because we don't see it doesn't mean it's not there. This is 1 multiplied to the variable, 1x. So it's like having 5 oranges minus 1 orange. We can subtract our coefficients, and yet we keep that variable. 5x minus x is equal to 4x. Another way we can look at this is like x plus x is 2x plus 3x, 3 of them. So if we were to expand this, we would see we have 2x plus another 3x. So that is, again, how we're getting to 5x. In algebra, when we write expressions, and even equations, we want to try to keep the constant last. So we can combine our like terms and then rewrite in simplified form. So for number 3, we have 3a plus 4 minus 2a. So because the variable a is the same and the exponent is they're both 1, we can combine these. These are like terms. So I'm going to circle 3a, and I'm going to circle minus 2a. Because the minus sign precedes the 2, so really it is a negative 2a. I can combine these together 3a minus 2a is equal to a. That's 1a. And then we can't do anything with that constant because it's a constant, it doesn't have a variable. So our answer is a plus 4, or if you prefer to write it with the 1 in front, the coefficient, certainly you may do so. You could write it as 1a plus 4. For number 4, we have 21a minus 4b plus 3a minus 6b. Remember, we can only combine like terms. So I'm going to circle the a's, 21a plus 3a. I can combine those. That equals 24a. So I just add my coefficients. And then for my b, I have negative 4b minus 6b. Over time, you'll be very comfortable doing this without having to do work on the side. But for now, if you feel more comfortable rewriting it and adding the opposite, you can do that. So negative 4b minus 6b, if we add the opposite, we can see very clearly that negative 4b plus negative 6b equals negative 10b. In algebra, we don't show the add the opposite, so we are going to write it as minus 10b. So our simplified expression is 24a minus 10b. Now let's take a look at the distributive law. If we look at the first example, 5 times 4 minus 2 in brackets, when we do something like this, we learn to use BEDMAS, or order of operations. And BEDMAS tells us that we need to do brackets first, and then multiplication would come after. And so that's really great strategy, and that's what we're going to do here. So we're going to solve what's in the brackets first. 4 minus 2 is 2, and that's going to be multiplied to 5. So the answer is 10. But there's a second way that we can solve this and get the same result, and that's called the distributive law. If we wanted to, we could distribute the 5 to both terms inside the bracket. So even though we don't have any variables here, we can multiply 5 times 4 and then multiply 5 times negative 2. And remember, that's a negative 2 because if we add the opposite, we would see that negative 2. So let's do that. So we're going to distribute, we're going to multiply 5 times 4 is 20. And then 5 times negative 2 is negative 10. And 20 minus 10 is equal to 10. If we don't have variables, using BEDMAS the way that we have done in the past is probably your best option, but it isn't the only option. And the distributive law becomes very important when we do have variables. So let's make a new example. Instead of the number 4, let's put in a letter, a variable, and see what we can do now. The problem with this is we need to simplify this, but we can't use BEDMAS because we don't know what m represents. So we can't actually do what's inside the brackets first. So our only option is to use distributive law. And when we do that, what we can do is simplify this expression so that later perhaps we can solve for m. So we're going to distribute the 5 multiplied to m and the 5 multiplied to negative 2. So 5 multiplied to m is 5m. Remember that the coefficient of m is 1. It's invisible, so it's really like 5 times 1, one of the m's. And then we can distribute 5 times negative 2, which is negative 10. So if we want to get rid of the brackets and simplify this expression, we can distribute the 5 to both terms inside the brackets. When you use the distributive law, you need to be careful with your signs and remember your integer rules. So for example 3, we're going to multiply, we're going to distribute negative 4 to x. Remember, that's like a 1x. and negative 4 to negative 6. So we're going to be multiplying to both terms. Negative 4 times x results in a negative 4x, because remember, that's like negative 4 times positive 1. And then for our second term, negative 4 multiplied to negative 6. Remember our integer rules. When the signs are the same, the answer will be positive. So negative 4 times negative 6 is a positive 24. So our simplified expression is negative 4x plus 24. Let's do a few more questions together, and then you can try the exercise 5.2. So we're going to combine like terms. Remember, both variables and exponents must match. Number 1, 3a plus 4a, they match, so we can simply add our coefficients. The result is 7a. For number 2, we have 6h minus 2h. Our variables match, so we can subtract 6 minus 2 is 4, 4h. Whenever you're doing this, if you feel a bit unsure, you can change the letter to a word. 3 apples plus 4 apples equals 7 apples. 6 hats minus 2 hats equals 4 hats. That can help a lot. Now let's use distributive law, and then we can simplify if needed. So for number 3, we're going to expand. We're going to distribute the 8 times the h and the 8 times a negative 3. Remember, that's a negative 3. If we were to add the opposite, we could clearly see that. 8 times h is 8h, and 8 times negative 3, that's a positive times a negative, will result in a negative 24. Our simplified expression is 8h minus 24. For number 4, we're going to distribute the negative 7 to the b. Remember, that's like a 1b. So negative 7 times 1 is still negative 7b. And negative 7 times negative 5 will result in a positive 35. So our simplified expression is negative 7b plus 35. For number 5, we have 2 areas where we need to distribute. Let's do them one by one. Negative 4 times r, it's a positive r. That will result in a negative 4r. And negative 4 times negative 3 is a positive 12. So my first brackets are cleared. Now I'm going to be adding the next distribution. So 2 times 1r, 2 times 1 is 2, that's positive 2r. And then 2 times 2 is 4. At this point, I can look and see, can I combine my like terms? And I can. I have 2 coefficients and variables, so negative 4r can be combined with positive 2r. Negative 4 plus 2 is a negative 2r. And then the constants can be combined. Positive 12 plus 4 results in a positive 16. So fully simplified, my expression is negative 2r plus 16. In this lesson, we learned how to combine like terms. We also learned how to distribute to remove brackets. We do this by multiplying each term inside the brackets. So you can begin exercise 5.2. And remember that when you are looking for like terms, they need to have the same variable with the same exponents.